IPv6 for a long time. And since I'm the first speaker, I decided to also use it a little bit as a little introduction, this talk towards the other speakers. So first, a very brief, quick refresher how some of the IP networking is done in mobile networks. It's very simplified. So don't take everything too literally on my slides, but it gives you a good idea if you're not familiar with the situation about the important topics that mobile providers have to deal with regarding IPv6. Then, of course, I have to show a little bit about where we are regarding our support in our equipment, and also where Nokia support is. Some common problems that we are discovering, because we are now in a phase where we are working a lot with providers to actually start to deploy IPv6. And I added a nice conclusion slide, because why not? I had the time for it. So the important thing about mobile networking is especially for the IP part, is that we run everything over a tunnel. And since we run everything over a tunnel, in this I showed here the current 3GPP version for 3G networks. But because we run everything over a tunnel, a lot of things actually get a lot easier, because that means that everything that's underneath doesn't matter. I mean, we can run that on a private IPv4 network or whatever, but the user will never see that. So that also means that we really only have to deal with a tunnel and make sure that everything there is going to be like IPv6 compliant. There is a nice draft recently written by a colleague and some other colleagues actually of mine, and they detail a little bit more about all this. And so I've listed here on the slides. Don't write it over. The slides are available on the web, and it's actually a nice introductory section that gives you a little bit more about details about all the nice keywords that I will be using. The other important thing is to set up a connection. You have to set up the PDP context, and that is the relationship between your mobile device and the core network. And that is all about like which gateway am I going to use, what IP address am I going to use, and what kind of quality of service level. The reality, the quality of service levels are not really used that much. The important points are really what IP address or IP address prefix or whatever am I going to use. What is an important difference, and what you will hear a lot of mobile people talk about, is this PDP context, is the fact that you can only have an IPv4 PDP context or an IPv6 PDP context. That makes things a little bit more complicated, because you cannot just open like a dual stack PDP context all at once at this moment. Luckily enough, there's lots of work going on to fix that, but at the same time, you know, from a computer science or computer engineering kind of perspective, it actually really doesn't matter. You just open two PDP contexts and you will have an IPv4 and an IPv6 address, no problem. But there's some consequences, of course, because this is mobile networking, and consequences is some overhead, state overhead, etc. And sometimes also some cost overhead, because some vendors want to have some money based on licensing fees in the gateways. So the important thing here is that it's a V6. You're going to get like a V4 only connection. You're going to get a V6 only connection. And if you are really going to do both of them, you will have to open two PDP contexts. Otherwise, we actually really don't have that many problems in a mobile network, because of all the tunneling that we're already doing. The thing is, but you will see a lot of people saying like, well, because we have to do this extra work, it actually is more attractive to go one version of IP because it saves us some cost, etc. But the preferred model for many people is still a dual stack, and it's actually fairly doable. And luckily enough, we are working on a dual stack version of the PDP context, so we don't have this problem in the future anymore. Let's see. I'll just skip this slide too. Then for address configuration for like a laptop, or like a cellular router. For dial-up purposes, here it's already shown basically a PDP context that actually does V4 and V6, because it will be there in the future anyways. But for dial-up purposes, it will be just like you will use like a PPP connection will get a v4 and a v6 address, and you're basically done. Or actually a v6 prefix, of course, because that's what we do. And important to note here is also that we do it based on normally on /64 prefixes per user, laptop, whatever you want to call it. And that's the simple, basically old-fashioned model. Obviously, there's much more of a trend nowadays to go a little bit away from old telco models of dial-up. I mean, it's a bit silly in a wireless network to still talk about dial-up, but that's really what it still looks like. And we're getting more and more incentivized to actually do something more sensible and make a mobile device a router. In that case, you will see that PDP context actually gets terminated on the mobile, and the mobile can then just do a route advertisement to the laptop and do something like net PT or net to actually deal with the v4 part. But even in that case, it's pretty clear you can just do dual stack and without too much trouble. So now we go a little bit to like more implementation details. Again, we are doing pretty good there. I mean, it's like there's a couple of different major mobile operating systems. I mean, there's one by Google, for example, but of course, Nokia uses a lot of Symbian. Of course, I have to show you Symbian. We can easily do there now an open IPv4 PDP context. We can do an open IPv6 PDP context. So it's actually easy for an application to do v6 networking or to do v4 networking from a dual stack perspective. There are some strange effects though, and that is people. On a mobile, you are much more likely also to open like a PDP context like for one application. So you won't really be using like IPv6 and IPv4 like from one application. You will be using either one. In practice, I don't think that really is a problem or something like that, but it can sometimes lead to confusing situations when people are working with this kind of stuff. I mean, we are much more used to like a single application that has access to all the networking components on a device. Then we have the MeMo series of devices, which will soon be called MeGo, because that's got merged with Intel's Linux implementations. There we are a little behind in the sense that it's v4 is not, or v6 is not quite supported in production versions of the software yet, but it is available on the net. The web link is here, so just take a look at it if you're interested and download it. I'm not going to say a lot more about this either, because actually Jan is going to show a demo about how this stuff actually can be used and be using IPv6, despite it's officially not really released yet. So, but it can all be downloaded. This is a slide with our product support. I'm very quickly going over it because I want to actually show you the more interesting stuff. This is just more for reference. If you want to know all the details about our support and hardware that you want to know, then just look at the slides and take a look at it. So deployment status. We are getting more and more focused on deployment. I mean, as a vendor, we have seen a lot of questions of people coming to us like, this IPv6 thing is not that important, stuff like that. And in the beginning, actually, we were one of the early guys. I mean, in 2005, 2004, we already had like IPv6 in Symbian. We had IPv6 in our GGSN and SGSN. So we could do all this stuff, but there wasn't really that much demand. We were actually too early. But luckily enough, we now start to see that life has actually gotten easier for us because we don't have to push anybody anymore. People are asking us. And we are ready for it, so there's a demo from Jan later about their deployments. I mean, we see T-Mobile USA now deploying. Telia and Sonera already had, like, for a long time IPv6 in the network enabled, but we couldn't talk about it, so people didn't know about it. But now it's like public, so we can mention it. The big thing that we see in those deployments and all the testing that we're doing with other providers is that, of course, we discover bugs, and finding bugs is important, and we need more deployment to find that. But one of the mantras that we've always used is like dual stack is fantastic and we need to do it that way and then we're done. Of course, what we are seeing now is more that there's also some different approaches possible, and I assume Cameron is going to talk a little bit about that as well, where maybe you should just offer like V6 only and just be done with it, perhaps as a cheaper service or whatever. But that's a topic that is getting more attention now, and we're getting more question about it, and that might be grounds for a little bit more discussion. Other common problem, I mean, it has been mentioned already, is like the business case for IPv6 has always been fairly difficult because it's just hard to quantify how much money you really are going to save in the long term versus all the costs that you make in the short term. And the big thing has always been that a lot of those kind of deployments were just a single individual who did something, and then this individual goes and moves to another company, and nothing happens to that anymore. We get bad routing on the internet, etc. The good news that we are seeing at the moment is that this is actually less and less of a problem. I mean, we don't really have to explain anything to anybody anymore. It's just like, oh, we need it because we have heard we're going to run out. And to me, this is actually a very important milestone I think we have reached, because we just don't have these problems anymore, that we have to continuously talking about the why and etc. But we all assume it's just necessary and just continue from there. As I said, from our perspective, it's actually, the packet forwarding, the support in the hardware, etc., is actually not that hard. I mean, there's a lot of ancillary issues, lots of network management problems, lots of other things that we would like to have IPv6 enabled, but are not necessarily that critical to start with and to get deployed right away. And one of the biggest things that we keep running into is actually not just the network, because the network is all beautiful and nice, etc. But it's actually the overall structure of a corporation, the overall support that you need in a corporation. And I've put here one example, very simple example on the slide about Telia and Sonera, where we had, for example, problems where the subscription management system didn't know that somebody actually had also subscribed to IPv6 servers. So every night when the subscription management services would do their thingy, the IPv6 subscription would be wiped out, and there we went again. And that kind of problems, it's like, of course it has been solved. I mean, it's not a big deal. But there's a lot of this kind of little problems that you find everywhere, and people just keep running into it. And it's just, while the networking people and the IP people know about IPv6 and know how to deploy it, it's all these other little pieces of the corporation who have no idea what you're talking about. And you're talking about support people, etc. So from our perspective, there's a lot of more real user experience now necessary. We need to make this next step to from just testing it to actually to let it on the loose to real normal users. Let's see. I have a brief conclusion because he wants me to finish up. So for us, from our perspective, dual stack is still preferred. We like it. It's simple. We have good experience with what we have deployed so far with other providers. But we also see some people, sometimes having slightly different requirements. We see some operators that said, we can offer a somewhat different service by doing V6 only. We see some people that say, we just like the simplicity of not having to deal with either V6 or V4. Of course, we like them not to deal with V4 anymore, but that's a different story, of course. There's things like dependencies on old handsets that are still in the field. I mean, one end, we are working in an industry where every 6 months everything gets replaced. But on the other hand, there's of course a lot of people that just keep all their old equipment around. And that's going to cause trouble, so you still have to support that. So just saying dual stack solves everything, well, obviously it doesn't for those kind of cases. Let's skip that. And then, basically the other thing that I already mentioned. I mean, we actually don't see that much problem actually anymore with the pure networking part of the story. I mean, we still want more. We need to do more testing. We know that bugs are found. I mean, when we were working with Jan on the T-Mobile network, we did find a lot of issues here and there. But those things can be fixed. I mean, there were no major stumbling blocks. All those things can get fixed. But we are now getting into that phase where yeah, we have to spread out this knowledge into other parts of the company where it's also very important, and where it's not always so well received because they don't care about things like V4 or V6. What's that? They just don't know about it. And that's it. Any questions?
Any questions? Thank you. Excellent. It's great to have Cameron Byrne from T-Mobile here. Thank you. Do you want to walk around? Or are you good?
No, I'll just take it straight on here.
Thank you.
All right. So first and foremost, I want to really thank Eric and Lorenzo for putting this on. Also for their efforts at Google. It's made a huge impact on the awareness and a huge impact on my ability to go throughout T-Mobile and say, you know, we really need to move forward. And the content's there. The iceberg is thawing with the chicken and the egg problem. So big thanks to Google, or Google, specifically Eric and Lorenzo.
Yes. And lots of other IPv6 people involved. Yes.
And we'd also like to thank Comcast, huge mover on the fixed line front. Facebook, yeah, you guys, and Symbian, because I want to be able to do a whole lot without handsets that work. So I'm going to move really quickly through this deck. I have a lot of slides, a lot of things I want to touch on. But a high-level thing is that mobile is easy to do IPv6 with. As David just pointed out, there's all these tunnels and things that make my life easy for deploying IPv6. I don't have, access networks that have a high degree of variability in them. It's very uniform. There's all these tunnels. The traffic moves around inside of tunnels. What's inside of those tunnels, whether the traffic be IPv4 or IPv6, doesn't really matter that much from the architecture perspective. T-Mobile's path forward is IPv6 only. So we have product cycles committed now for timelines of handsets that will ship to stores that will be IPv6 only. It's not soon, but it's pretty soon. It's within product lifecycle scope type soon. So we are planning on bringing IPv6 only handsets to users. So that's important. It's especially important because some things don't work with IPv6 only networks, and we'll talk about IPv4 literals and what they mean to content network providers. Today on our network, we have an IPv6 only service that's nationwide, so 200 million covered POPs or people in the United States can get IPv6 service through T-Mobile's wireless network today. So I'll start into the slide. So as David kind of pointed out, here's like the general gist of the mobile architecture. As you can see on the diagram to the right, you can see that there's a cell site. It aggregates up to a local aggregation point, and then it aggregates to a mobility anchor. All those links between these steps at the cell site, aggregation for mobility, and the mobility anchor are encapsulated in IP. Today it's IPv4. It's called GB for kind of close to the access side, and GN closer to the core side. Closer to the core side. So I was able to turn on IPv6 to handsets without actually telling anybody in the RF network engineering group, touching any cell sites, touching any of the core aggregation network. All I had to do was change the IP anchor, the GGSN node, as it's known, to support IPv6. So at T-Mobile, IPv6 is a priority. This is my main message. This is why I'm coming in and talking to you today, is to say that IPv6 is a priority. The problem statement is we've run out of IP addresses. Mobile providers do lots of things that normal network engineers would think are crazy. Reusing 10/8, multiple times, bogon addresses, all kinds of things that are unhappy. And people talk about CGN, but really CGN is already in the mobile world today. We do a tremendous amount of NAT, as does AT&T and Verizon starting to. Just talking to the gentleman from Sprint, they don't do it yet, but they're staring down that barrel. So it's very common to have a lot of NAT in network. So we're going to need IPv6 to continue growing. We can't keep up with the NAT. We don't want to reproduce 10 space over and over again because that kills end-to-end services like SIP or an IMS, which are really the future of mobile telephony. So we need IPv6 end-to-end. Dual stack doesn't really work out for us. I'll get to that in the next slide, but the address environment today is there's bogons, let's keep growing, need IPv6 end-to-end. I'm very optimistic about end of year 2011 that 50% of my traffic can be IPv6. That's because I send a whole lot of traffic to Google, like a lot, and I send a lot of traffic to Facebook, and I send a lot of traffic to Yahoo. And those guys are in this room and they're thinking about IPv6 and they're moving that rock up the hill for me. So I am very optimistic that there will be a 50% content tipping point for my network, knowing what protocols my network has, who my destinations are. I feel very confident about that. So I need the long tail to come along too, but for the long tail I have technologies that'll help me bridge that. That'll be NAT 6.4, DNS 6.4. There's a presentation tomorrow on that. It's good for the network guys and the content guys to all understand how that's going to work because it's important. Some stuff is broken today. Major things are broken today. But we're going to have to keep moving forward. There's no traditional business case for IPv6, so this has been a problem. Usually how things work through a telecom network is that there's a forecast and there's a product guy and they come up with this plan and they get together with the forecast and the budget and the marketing and they move it through and there's money and there's a project manager and there's no forecast for demand for IPv6. There's no revenue. It's kind of more like there's a little bit of a business continuity thing. You can say that, our business is going to fall apart in 2015 because we can't address anybody and CGN's going to, won't be maintainable. So the entire business is lost. You can say something like that, but it gets hairy. So it really has to be championed by individual contributors, kind of taking the initiative to say, hey, this is easy and we can do it. And really it is low-hanging fruit. As I said, I rolled it out to 20 million people that are in radio coverage or 200 million people that are in radio coverage. So really it's a small team that can do that. I understand it's harder in a lot of the access networks, but wireless 3GPP, it really is pretty easy. So what the IETF has been telling us for a long time is that the way to move forward is with dual stack. Dual stack, as David pointed out, costs more money for mobile operators. It's more complex, and when I say more money, in my particular instance, it costs exactly 2 times as much money. So it's not very easy to say to my VP that, hey, let's do IPv6, and it's going to cost twice as much money. Not going to work. So we're really eager to find solutions that are IPv6 only. And with this friendly user trial that we've had, we've been able to position it as such.
Cameron.
David.
Well, twice as much money for your GGSN gateway.
Entire packet core.
The entire packet core, that's precise.
RNCs do twice as many PDPs, will mean twice as many IUPS, twice as many mobility events. It really trickles down into exactly twice as much money. Especially when you pay for your packet core by PDP.
Yeah, and that part I understand very well, but there's a lot of other parts where it's probably not quite as bad.
Right, well, so when I say entire network, I mean entire packet core. Yeah. So, but that comes in release 8 and release 9, so we're not there. So the question is, what about dual stack PDP context? So dual stack PDP context is defined in 3GPP release 8 for LTE networks and in 3GPP release 9 for non-LTE networks. So yes, absolutely, you can do that in those networks, but I don't have a release 8 network. I don't have a release 9 network. In fact, nobody has a release 8 or 9 network today. So, but I do have address problems today. So if you define the issue as I'm running out of IP addresses, I don't have IP addresses to provision to my subscribers today that are good. I can't give them public addresses. I can't even give them 1918 addresses. If you define it like that, then it becomes dual stack doesn't solve my problem because I still need an IPv4 address. I don't have an IPv4 address. So that's, strategically we want to be correct in choosing the path for IPv6. And strategically, everybody agrees the end state is IPv6. So let's go to the end state and work backwards and see how we can get there. And if you look at that without all the notions that dual stack is the way to go, you don't see dual stack on the path. So quick diagram about how this all works. Cell site, radio access network, SGSN, these things all work. It's kind of detailed, but the idea is that here's my friendly user trial network. Everything to the left in that where it says RAN, SGSN, IP backbone, notice that there's not really a lot of changes there. There's the database that authenticates you has to say you can do IPv6. The feature has to be turned on in your SGSN. Everything else is the same. The lab network is the GGSN, the NAT64, DNS64, that's all in my control. So it really is pretty easy from an access network perspective to roll this out nationally. And in fact, it has been rolled out nationally. So friendly user trial findings, so it works. Email works, websites works, whole lot of apps work. Some apps don't work. The fact that there's a whole lot of apps work, this points to the notion that you can do everything over IPv6 today, IPv6 only networks. And you can do everything within reason over a NAT64. Presumably anything you can do over a NAT network today, you can do over NAT64. But some things aren't going to work. We think that good programming practices, which there's a talk on that tomorrow about how to make that work. We need to get everything over into this camp that works. So things to keep in mind. I'm here to really talk about content providers because I'm an access network, so I can do all the access stuff. The content stuff's the stuff that's out of my realm, and I really need to cooperate with the content guys. I want to be a really great partner to bring your content to our shared customer. IPv4 literals are all over the internet today. IPv4 literals are IP addresses embedded in XML documents, HTTP, HTML. It's when you have a IP address like 1.1.1.1 or whatever your public IP address is for your service that's embedded. It breaks NAT64, DNS64. There's a talk that we'll go over that tomorrow about how those work. But the key is if you have IP addresses in your systems, we need to work together to fix that. Otherwise, there's going to be some breakage. So, and an easy way to fix it is to use an FQDN. FQDNs are a good idea anyways. So the quicker you can get there, the better. Here's some slides I just wanted to share to help spur some questions and some comments. So here's a major online retailer that also deals in video streaming. Notice that they are passing, so you see all this traffic here. It's all IPv6, it's all DNS64, NAT64. It's working great, page loads great. I go to launch the streaming, and here comes this IPv4 address transmitted inside my IPv6 packet in something that's labeled HTTP XML, and it says connect to this IP address, this IPv4 address. It could be a name. It could be a name. You're exactly right. If this were an FQDN, it would work. Huh? Okay. That's right. But the point is that this is breakage here, and we've worked with a lot of great people to fix this breakage in various places. MySpace had this with Akamai. We worked with them. They fixed it. They rolled it out in their production network. It was great. They're a great partner. Yahoo had the similar problem. They fixed it. Great partner. Hulu had the same problem. Before we reached out to them, they fixed it. So in part of my regression testing, I want to have my customers to have a good experience. So I periodically go through the Alexa list of the top 100 sites and see what works and what breaks. Hulu fixed it on their own, so they had a new video player out, so they fixed it. But there are people out there that are broken. There's other sites that don't work for various reasons. I don't know why. Here's another thing that I want to kind of put out there in terms of what IPv6 enables. So today, as David was saying, it's very hierarchical how this traffic moves up the network. As we grow with 4G and we start getting 100 megabits per second to the handset type of thing, We need to start not taking all that traffic into centralized nodes. We need to start exiting it closer to the cell site. So IPv6 allows us to get there because we no longer have to aggregate all the traffic for address purposes. We can exit it out. The cell site may have a GPON connection itself, and it'll get you going faster to where you need to be instead of backhauling your traffic to some far-off city where we have a big aggregation site. So look at that slide and think about it. These are things that work today. Amazon.com's webpage works. There's West George in my Facebook. He works. And that's not the V6 version. That's the DNS 6.4, NAT 6.4 version. So, I can make these pages work in my lab today. This is an IPv6 only experience. Some things don't work. IMDb, it doesn't work. It's not an IPv4 literal, but I don't know why it doesn't work. It's on the top 100 websites. So we need to work through that. And all the other content players need to help us work through that. The best way to work through it is what Google's done, really doing IPv6, announcing their quad A's, because the fact is that if you're a content provider and you don't announce quad A's and you don't announce your traffic as over V6 transport, I will, and I'm going to do it with the CGN. I'm going to do it with the DNS 6.4, NAT 6.4. I want it to work either way, but my guess is that it's going to work better if you just do it natively. Here's another thing about end-to-end. And we talked about this in firewalls a little bit. Quix offered an innovative service for video sharing. They're doing it or they have to deal with mobile subscribers over NAT. When they have to do that, they have to take all the traffic into their servers, and they have to pinhole it through the NATs. Whether it be an AT&T subscriber or a Sprint subscriber or something like that. If you weren't doing that, you could send the media end to end. And you don't have these capacity problems. You're just, doing the signaling for session setup. But when there's NAT, you have to send the media through some rendezvous point of a sort and make it go. So future scalability will definitely be better with IPv6. Just a slide about how /64 per UE is a lot of traffic or a lot of addresses, and that's it. Questions?
Thank you. Yeah, we have a few minutes for questions. 5 minutes for questions or so.
Please, I really like questions.
Yeah.
Martin Levy, Hurricane Electric. You glossed over something, but I want to just bring you back to it. Mm-hmm. You talked about the fact that each cell site can have enough address space, and you don't have to bring stuff back to NAT it in a central location. That's phenomenal, and that's a fundamental difference between V4 and V6. Do you have any idea how that will change traffic patterns for mobile players? I mean, I'm not on your network. But I know half my packets are going to Atlanta, even though I'm sitting here.
And then I probably know who your provider is.
Anyway, can you just address that, because that is a fundamental difference between V4 and V6.
Absolutely.
Which will affect us network-wise.
Absolutely. So it's obvious that one of the things that we've done at T-Mobile over the last 5 years is we've really decentralized our network, so that we probably are more decentralized than any other player in the United States in terms of having users be closer to their mobility anchor point where they exit out to the internet. This brings this down to the cell site. It comes down to an issue. If you have 300 or 3,000 cell sites in Manhattan, each one of them is capable of doing over 100 megabits per second. Where are you bringing all that traffic to? No, not even the geographic location, but now you have a site that's carrying a physical location with 3,000 times 100 sites worth of traffic. That's a lot of liability. If you can, and that's a lot of backhaul costs too. Huge amount of backhaul costs. If I can exit that via GPON or something like that at the cell site, it's a better user experience, less latency, and cheaper for me, because now I don't have to have a big honking data center to move all these bits. I can distribute them out closer to the user and get them routing shortest path as quick as possible.
Kenny Hong from Cisco. Is T-Mobile in conversations with other operators to understand the inter-operator dependencies in roaming and local breakout scenarios?
Yeah, so the local breakout stuff is in the 3GPP, as it's called SIPTO and LiPo or LIPA. Those things are more kind of near the home E node B, so it's absolutely part of the 3GPP process. But what I've been proposing is not necessarily a new standard, but terminating the existing S1 interface at the cell site so that it works with existing standards for the LTE scenario. But it's not gotten a lot of traction because a lot of the legacy vendors like to do things the legacy way. But the roaming case is so roaming is so far out. We've reached out to roaming partners about IPv4 or IPv6 roaming, and they've all responded no, even though we know that a lot of their networks do IPv6 roaming today, as per Frederick's testing.
Jan Christensen, TDC. So I understand you launched this service for more or less all of your users. Are you doing that on the existing APN, or did you went ahead and create a new APN for those users so they actually have to change the APN settings in the terminal?
So I'm sorry if I was confusing. This is for a friendly user trial. So this isn't all my users. This is all my network, but only a friendly user group of users. And in telecom, we call beta a friendly user trial.
Yeah, okay, so you go ahead and manually provision these users in the HLR with the specific PDP type. Okay. A second question, have you found any other terminals than the Symbian-based terminals that will do V6?
No. This kind of goes back to when Lorenzo and I first started talking about IPv6. He said, I'm going to put it on Wi-Fi because that's easy to do, and I have a Wi-Fi access point. If you build me an IPv6 UMTS network, I'll start working on it. So I said, okay.
Yeah. So hopefully there's some Android developers around here listening today.
Yeah. I hope so too. It's definitely a theory of build it and they will come. So I built the IPv6 network, bring the terminals.
I blame Qualcomm. My Nexus 1 won't do V6, and that's because the radio baseband layer won't do it. It's supported for the, I believe, the proprietary protocol that their OS uses, but if you want to use the raw access to the chip, you can't do it. It's not supported. So on the Nexus 1, it's a non-starter.
And I'd just like to point out that in the last month, T-Mobile met with all of our handset manufacturers and all the chipset manufacturers that we purchased from and told them our plan so that they can align their roadmap.
I wanted to ask another question. Can you quantify the impact on latency of what you said before, terminating V6 traffic locally, whereas you have to backhaul V4 to a central NAT location because you don't have enough space? And I asked this question because there are certain content providers that do care about latency, and saying that quantifying the latency changes and the impact on geolocation and things like that.
This will give you very granular geolocation.
Right. So if we could quantify that in some way, then that certainly does become a good reason for content providers to do V6.
Mm-hmm. Yeah, so it's quantified just in the latency backhaul between that you would have to have it. So whatever the latency backhaul is between a cell site and the application and the regional aggregation node, which would be 20 to 30 milliseconds on a round trip.
Numbers, yeah, exactly.
Right.
So you glossed over the IPv6 address assignment a little bit at the end. You envision, particularly for the privacy challenges, do you envision that the device will have a permanent address for a long time, or what are you seeing, or is it if you have a privacy feature so it doesn't look like a cookie, etc.?
Mm-hmm. So I personally have a lot of I choke on the idea that every UE needs to get a /64. I accept that that's the industry, and I'm not going to pick that fight. But at the same time, I have the numbers here that I can easily go through 30 bits of space. This is my initial plan for IP addresses, is that I'll use 30 bits, and that's it. So that's a lot of it. From my perspective, that's a lot of addresses. But I'm not going to pick the fight about go back and re-standardize everything. The fact is that all the vendors for 3GPP gear have hard-coded /64 as the interface type that every mobile subscriber will get. So it's not an option.
Jari Arko Eriksson. So I wanted to touch upon this V4 address literal issue. And we've seen that as well. And while I didn't personally feel that that's I've been on a V6 only NAT64 network for a couple of months, and I didn't feel that that's a big issue for me personally, but we've done some measurements, and I'll talk about them more tomorrow, and there are some. But what I wanted to point out is that seems almost like a one-time effort, that we go through Alexa million and we fix everything, we complain.
Right.
And that probably, I mean, we've done part of this work already, but probably needs some cooperation, because me as a research guy in some vendor organization doesn't really can't go to Amazon and say that you must fix this, but someone who has millions of users behind them probably could. So some cooperation may be needed.
Right, and that's exactly why I flew down here. I usually don't attend conferences and travel, but this the IPv4 literal issue in content will cause breakage, and I want to work with the content providers to partner with them to make sure that there isn't breakage. So we're over a year out from where I would ideally like to see IPv6 handsets in stores, what Google has done, that's the best way to do it. You publish quad A's, you host your traffic as IPv6, you're 100% there. That's amazing. You know what? They're my number one content provider that my subscribers go to. So I got a real big win in my side pocket about how much content I can move on IPv6. But there are major websites out there.
We have to cap them
right there, so that where they're passing IPv4 addresses.
Have you considered building a not a wall of shame, but a sort of a collaborative website which would perform periodic monitoring of high impact websites to identify the problem and help them fix them? It wouldn't have to be a T-Mobile effort per se. You could coordinate with other interested parties.
Yeah, it's well, as you see here,
they're inside packets, not on URLs all the time.
Right. It's in these XML documents. They're interactive, so it becomes pretty difficult. But we definitely need to get there. And as my friendly user trial matures and gets larger, that's definitely the kind of exchange I want to have, because that's the purpose of the friendly user trial. Get the users, the content, the network together. Let's all make it go.
HTTP is an important protocol, but there's a lot of other protocols that have IP address literals in them that we also need to get fixed or have applications deal with.
Good point.
Okay, so no terminals besides Symbian. Here's one for you, and it's also rendering internet movie database for you, so fixed that one. And if you don't want to use Quick, you can use Blink TV instead. That works. So there are solutions. And I have an Android 2.1 cellular IPv6 phone right in here.
And if you want to become part of the friendly user trial and help us move this rock up the hill, please contact me. I'm always willing to help get folks in the community together to get on IPv6.
Thank you. Thank you very much.
My name is Ben Parker. I'm the Director of Wireless Network Planning at Verizon Wireless, obviously. I just kind of use Verizon Wireless as a tagline. I actually work for Verizon Corporate, so I just kind of get to fake that I work for Wireless periodically. So just a quick background on our problem. So we actually have more than 45,000 cell sites, way more than 90 million subscribers. Okay. And with LTE, as T-Mobile is mentioning, our peak sector good put is actually going to be upwards of 80 megabits per second, 3 sectors or more per cell site. So it's some pretty big backhaul. The cell site to the MITSO requirements are huge. Interestingly enough, you're the only other person I've ever talked to on the planet who talks about local breakout at the cell site. I'm just absolutely thrilled about that, by the way. And then we have about 200, greater than 250 cell sites per MITSO in the normal problem. So if you look at today, we're backhauling in the old IP backhaul network around 600 megabits per second from all of the cell sites assigned to that MITSO to the MITSO. As we step forward to later this year, that goes greater than 20 gigabits per second. So not a big amount of bandwidth in what a lot of the service providers consider, but it's a huge step for a wireless ISP and a wireless service provider. So what we did, back in the Bell Atlantic mobile days, we had an analog wireless network called CDPD, and it was extraordinarily popular with police departments. And what was interesting is the police officers would look up your driver's license or whatever, and they'd get information back. And periodically, the police department would actually reach out to a police car unannounced over the IP network. So we needed a globally unique public IP address to every single police car. Well, that seemed really popular and reasonable back when we had about 10,000 police cars on our network nationwide. Then we moved up to 1XRTT, and the decision was made to continue to use globally uniques. Well, then all of a sudden, we scoot forward a few years, BlackBerry's getting a little more stressed, then Droid shows up, and there's no IP addresses to be found. So we very quickly actually started to federate the network and deploy NAT44. And so we're now, we have 40 overlaps of the RFC 1918 space nationwide, and are pretty well distributing that. So this is kind of the good news and the bad news. The good news is we have plenty of 4.4 NAT resources to go for a long time, but we are certainly pushing towards V6 pretty hard. So as far as LTE, when we launch later this year, LTE is going to have everything is going to be dual stacked, and of course the IPv4 address is going to be 1918. The V6 address is going to be public /64. All the devices are going to have 2 IP addresses. One's always going to be registered to the VoIP network, and the other is going to be for the data APN. So the first IPv6 devices are really going to be available in 4Q. And yeah, it is compliments to Qualcomm. Working really, really hard with the vendors to make sure that we can support V6 in the devices. And as soon as LTE comes online, that's really the demarc point. Handsets will become more and more prolific with V6 starting in the first quarter of 2011. So that's our real drop dead dates. So because we're a CDMA network and we're moving towards LTE, which is 3GPP2 moving towards 3GPP, it really represents a greenfield environment for us. So as we move from IP backhaul to Ethernet backhaul, every one of the cell site routers is addressed with an IPv6 address. It's every single one of them. All of the MITSOs, all the aggregation routers are all IPv6 addressed. We were able to literally readdress the entire network in about a year, simply because it was a greenfield. The MPLS core, it's 6VPE, that's been completely turned on, and life is good. And the only bad sign is that the legacy infrastructure, the EVDO and WXJTT network, is going to remain IPv4 up until they are shut down. It's never going to change. It's not even worth the effort. There's not a lot of network elements and so on. So as far as network services, what we're really looking at here is to create islands of IPv6. So the IMS core, that's absolutely going to be V6. It always has been V6. It actually really isn't supporting V4. We're going to NAT everything into it via session border controllers or whatever is appropriate. The over-the-top services are IPv6 when practical. We're working with all of the content providers and various other folks to make sure that that's IPv6 from the start. And we're really pushing hard for all of our existing services to be migrated by the end of year 2012. And it's a fair number of services, but there's a small number of ASPs that are going to take a while to migrate. So we're giving them a couple of years. The ASPs, they're being driven hard as well. And of course, the internet, we're going to have the 6 and 4 internet available from the get-go. DNS, DNS is a huge issue for us. So we haven't. We're deploying the DNS servers out towards the edge right now, re-engineering the caching architecture, supporting the initiatives that Yahoo has been pushing forward, and then we're also going to start actually asking for the whitelisting programs to start coming up in the next few months. Our biggest challenge, quite honestly, is that we've went from circuit switched, good old-fashioned DS1 serving every single part of the network to all IP in less than 2 years. So the folks who actually operate the network didn't even have time to get used to saying IPv4 before they had to start saying IPv6. So we're really having a great deal of problems managing that migration. We're really leaning on our vendors very, very hard. But the folks are coming up online. Training is a big deal. The academic training, just sitting them in a class and teaching them, that's really great. The memory of that lasts I'm estimating about 17 minutes. As soon as the first beer gets in their hand, everything they learned in class goes away. That's fine. The web-based classes, everybody asks for them. Again, the value of those is almost as much as the academic classes. What we're really happening is outages. As soon as we have an outage, people learn really hard and learn fast, and they never forget that. So it's actually really kind of sad. This last few weeks, we've had a couple of interesting outages that are really, really quite complicated, really something that I wouldn't have predicted. And so, well, they're lessons we've learned and will never, ever do again. So a few of the executives are really pissed off about it, but at the end of the day, I'm glad the outages happened today rather than 6 months from now when LTE launch. But basically, that is what we're going to be doing. We're dual stacking. Every one of our devices is going to be a smartphone, starting on the 4G or the 4G network, and that's where we're at. So that's quick and easy, dirty. So got all the T-Mobile questions done.
Thank you.
So, thanks.
Excellent. Questions? Go ahead. We got time for questions. We do, absolutely. No. We brought them out here, so.
I missed if were you going to have the dual RAB, or are you going to be tunneling the V4 over V6? You said dual stack light. You just quickly ran through that. I didn't catch what you were doing.
So each phone is going to have dual stack.
So you're going to have two RAB, two PDP contexts.
Absolutely.
Okay. You're not concerned about the comment that was made about cost?
LTE, they have the dual stack PDP context. The
Right.
multiple beast is available to them.
Right.
Okay.
But I mean, quite honestly, I am not concerned in the least because the cost of losing a customer is way more than the cost of my RAN. So I'm willing to throw money at the problem to make sure that doesn't happen. It's actually kind of funny is we actually asked, there's a business case for this, for an H323 ALG to be put on the carrier grade NAT. The business case, one, to actually have it developed simply because the fear of a potential customer having a 323 running over the network. I'll guarantee that nobody's running 323 over the network. We'll never use the ALG, but we're going to pay enough, pay for it just simply to mitigate that risk. So it's pretty scary.
Thanks. Ralph Wallace with Command Control. You're the second person to come up and say that training has some challenges.
Mm-hmm.
We just got done doing a training course of implementing IPv6 and securing IPv6 for DARPA and the Missile Defense Agency.
Mm-hmm.
And we did this in a way so it was in the format of a transition plan.
Right.
Letting people know, okay, this is how you get familiar, and here's a common language, and then here's how we're going to be securing it, but this is all preparatory to actually going into a transition.
Right.
We did this in partnership with DARPA, in partnership of understanding their infrastructure, things like that. We got a lot of great comments back saying, holy crap.
Right.
How come people haven't told us this before? The lack that you had for training, is it because, as you said, there's atrophy because people don't use it? Was it the sequencing, the training timing? And Ron,
Yeah.
this is you said earlier about your training too. Is that the same thing about sequencing of setting things up?
So if I had my druthers from a sequence perspective, is I would have all major outages on a predictable schedule, and I'd have training events. Training events would end at 7 o'clock, right before maintenance window started, when these outages would occur. The problem totally is timing. It's simply the atrophy. The holy crap part, we get that all the time. The other thing that I get all the time is when we do have a V6 related outage or something like that, it's, well, why didn't we have training? Well, we did. It just, the relevance of the training is dictated based on that particular outage. So it becomes, once you get hands-on, once you characterize, once all of these things happen, so much more becomes relevant. And that's what I found. In fact, my experience in the military, you can go to Fort Irwin and go to wherever you need, Huaychuca, and do all the training you want. You can spend months out in the field and you never learn anything until the first day you actually go live and somebody's shooting at you. That's
when I reported on my first ship. They said, "Okay, forget everything you learned. Now you're going to do it right."
Exactly.
I know what you mean.
I was spending a lot of time doing a network re-architecture project, and one of the guys on the team's a former submariner, And he says, well, you can work out all the problems, but they'll just make a dumber sailor. And so, you you just can't win. It's just.
Yeah, thank you very much. That's part of the thing about training and training at the right time, the right amount, those type of things.
Yeah, I would love to know the answer.
2 questions. So one is, do you anticipate firewalling the IPv6 addresses of the users?
Based on current PMO, yes. What that really looks like is TBD still. I think it's going to be fairly light.
Okay.
At the end of the day.
But there'll be there will be stateful devices between UEs and.
Right.
content.
Yeah. No. Right now, at each one of the gateways, there is absolutely a stateful device that is taking a look at that. My concern is that, well, how much, what do we really need to do? How much do we really need to actually do that? As compared to IPv4, where there are some really pretty interesting attack vectors, V6 is a little bit tougher. So, what are the attack vectors that we need to worry about? And I think that again, that's like training. We're gonna see a lot more evolve over time.
And we've reached out to folks about in GSMA and some other organizations about V6 roaming. So have you seen anything back? Because when we asked, pretty much the roaming people were like, if there's somebody thinking about IPv6 in some carrier somewhere, they're definitely not in the roaming department.
Well, yeah, but so we always, when we talk about roaming, we're specifically talking about LTE. So it doesn't even don't even go to V6. So we get big guttural laughter coming from people when we talk about LTE roaming, because the networks really aren't coming online for a while. So we're going to start having those discussions more and more, I would expect, next year. And then people are going to start talking about V6 after that. But the last conversation I had related to roaming and or V6, it was a non-starter. I'm glad you're hearing
I've seen the same thing. It's unfortunate. So what we have to do is, in our handsets, we've been going back and telling, in a roaming scenario, fall back to an IPv4 APN.
And that's all. I mean, we're just planning on that. So and we're pushing one voice, right? Because the call servers are a little bit obviously a problem. So in one voice, that is exactly the scenario there, and I think that data will naturally follow that path.
One question following on from the earlier one: if you don't plan to provide, if you plan to introduce stateful devices between the UEs and the rest of the network, how are you going to deal with UEs forming random IPv6 addresses and sending you traffic and overflowing your state?
So, because
that's allowed by 3GPP, right? The UE is free to do whatever it likes and send it packets because it's got its own /64.
It is allowed. The issue is, so all packets have to go to the gateway, and so the issue is allowing the packets to move horizontally at that point. So in our current network today, it is not allowed unless under specific agreement, and at that point you can have at it.
What about tethering and things like that?
So that is totally a marketing issue, and so when marketing turns that on, then those rules and those questions get answered. If you just look at a basic subscriber today, the answer would generally be it's not allowed. So as tethering comes on, we're going to see more and more interesting things happen.
So if a 3GPP compliant specification sort of device forms another address and another address, then it's not going to work. And is that?
Yeah.
It's just there are issues here, right? So it's
right.
But we should take it offline, probably. But sorry.
What it comes down to is just permit any out and deny any
in. Right.
So that's how these scenarios look. But as soon as you have that stateful device, it really comes into looking a lot like CGN with IPv6 on both sides.
And there's a lot of state there. Yep.
Yeah.
I think so. If you're effectively saying that you can only allow 1/128 coming up from the handset unless you pay more in your license agreement, then he, writing code for Android, is going to go, oh, okay, well, if I've got I can do that anyway. I can allow tethering, but I have to build in a NAT. And we did that with V4. Let's not do it in V6.
Yeah, no, I don't think we're going to say build in the NAT. I think
they'll do it anyway. That's the point.
So there's an interesting thing that happened actually complements to the part of the community in here is with the open networks. So with that open networks, you can do whatever you want to our network. The side effect is you get billed for it. And,
I've read the latest version. Oh, I've read a recent version of the publicly available specs.
Right.
It is a little. It's vastly better than it was.
Right.
It's a little confusing in some places. It says shall, should, where it says that you should form only one IP address, and then
Right.
paragraph full of shells. So but yeah. So that is my concern because even talking about it, as the guy who wrote the V6 code in Android, I've been talking with other device manufacturers on how they would do V6 on LTE, and they're saying, well, but if we need to implement tethering, what are we going to do? And I said, well, the most natural choice is for you to bridge, and so you just send out the RA, and whatever tethered device behind you will connect, and you can limit the number of addresses, but you can't limit what they're going to do.
Right.
So if they limit to just one address, that will result in that.
Right.
And that is not what applications are going to expect in V6. So it's going to break applications.
Right.
So since I'm one of the guys writing the standards for 3GPP, actually what we are doing is trying to get out of the situation having NAT 6.6. So that's why we recently also introduced in release 10 prefix delegation for IPv6, so no one can say, but I only get 1/64, right. So I have to do NAT 6.6. And this is also one thing that we need to discuss further in the community is what is IPv6 address waste? Is it waste to do prefix delegation to mobile phones? Where's the limit? What's the situation here? But to answer your question here, Lorenzo, it's allowed to have any kind of whatever bits you want in the 64 bits, lower 64 bits. You can have whatever you want. But then if you force any kind of firewall or whatever, then that's up to the operator. But the specs doesn't say that this is an option. And about shall and should. Yeah,
it's a Verizon spec.
It's a political organization. Sometimes a shall is too hard for someone to bear, so then it's going to should. So that's why.
Yeah. And that document is, as you've seen, that is a living, breathing document. I would expect that we're going to get some more specific questions related to tethering, and that'll get worked out.
Last comment, hopefully quick. We got to get to
Rajiv Kurli, Cisco. Part of Cisco which makes mobile gateways which are deployed. So the /64 is what you hand out. The link local address is the only one where the IID is provided by the gateway. But beyond that, the mobile can use whatever the lower /64 it can use.
Great. Thank you. You're fortunate enough to have Jan. You came all the way from Slovenia this time? Yes?
Yeah.
All right. Well, thank you.
Hello, I'm Jan Zorz from Slovenia. I'm a bit jet lagged, so sorry if I missed something. Okay, I come from go6.si. That's an institute for IPv6 in Slovenia and initiative. And let's see if this is working. I wrote this on Mac, and I have bad experience with PCs. Okay, this is the agenda. Few words about what we are doing there. It's about awareness and putting people together. And I will present what we did. We were like a catalyst for our 2 mobile operators in Slovenia to deploy V6. And I will show you how we did it. And I will, at the end, try to do a demo from this phone. I think this phone is becoming the most famous phone on this conference lately. So let's see. Robert and the gang from Ripe Labs did the ripeness measurement, or they said that Slovenia is most IPv6 prepared country in Europe. You can see it there. That chimney, that's Slovenia. And we also have the most traffic on the V6 in Europe. So I I've been asked to explain on a RIPE meeting in Prague how we are doing that. So we founded the Go6 Institute, like an IPv6 initiative in Slovenia. We are 2 million people. We are a small nation. We literally know each other. So we are a not-for-profit organization, and we have strategic partnership with ARNES and LTFA. ARNES is our academic research network, and LTFA is a laboratory for telecommunications on faculty of electrotechnics. And we are open platform. We're based on membership. We have all major ISPs, mobile operators, content providers, and integrators, and everybody else aboard. And we are financially supported by our members. They pay annual fee, and so we can do our job. The Go6 is steered by expert council, which is formed from representative of the government, telecom post regulator, from academic research network, faculty, industry, and me as a chair. So we as an expert council, we sit down, we talk to each other, we settled out things, and when we go apart, government does their part of the work, regulator does their part of the work, and so things get done. IPv6 is being deployed. So our activities have IPv6 working group. We organize IPv6 summits. Martin was keynoting one of them, Jay Levy, and that was a brilliant job. Thanks, Martin. Yeah, these slides are from RIPE meetings. So third was it's already over. So what else we do? We do 6 deploy workshops. I don't know if you know 6 deployed. It's EU stuff for doing the presentations and courses all over Europe. We are hosting the 6 deploy lab. We are also involved in A+P draft with Randy and friends. We are forming the Go6 Academy, and we are testing lots of stuff. We would also like to have Ericsson's NOT 6.4 implementation to test and see what's working or not working. So what's our goal? What's our mission? We make people talk to each other about V6. This is the main stuff. People need to talk to each other. Basically, we need to aggregate knowledge and make it available between the members of Go6 platform. And this is the most important one. We connect government, regulator, ISP, and industry between each other. We make them talk to each other. We make competitors talk to each other about V6. And this is the main driver for deployment there. So we became a IPv6 pivot point in Slovenia, and apparently it works. So from this point on, I'm a proxy presenter. I run the Go6 Institute. And we made these guys deploy V6 on these mobile networks together. So at the end, you will have the addresses for more specific questions. If I can't answer them all, then you can mail them to that stuff. So this is T-Mobile network. This is a very small mobile provider in Slovenia. They even don't have the coverage in all Slovenia. So, but they deployed V6, and these are pictures of the phone, where I just went to the ripe.net page, and you see that it's coming from the IPv6 address. And I tried the IMAP login and sent some emails from that phone. And you see that this thing is actually working. This is the network. This is their IPv6 pool, and basically it's like most of the pictures you saw this day. There is a trick. I don't know if Nokia fixed that, but they have the redirection hack, because currently in Nokia SGSN or GGSN they can't have dual stacked APN, so they redirect the traffic to 2 different APNs. So
Yes, it's fixed.
thanks, David. I knew I will hear this. So these are versions of the software used. You can just download my presentation later and copy it. We are already using not just for testing. We don't know currently the list of applications that are broken with NAT, but with Ericsson guys we spoke and they said that we will update the list between each other. So I think this is going to work. So this is the other one. This is Mobitel. They have different stuff going on, but still it's working. And Mobitel have the coverage in all Slovenia. So if you go out to the woods or on the walk, and you go out of T-Mobile coverage, you connect to roaming, in roaming mode to Mobitel, but V6 is still working. So we have national IPv6 roaming totally working. This is their network. They gave me the picture that is pretty complicated and small to read, but this is what I got from them. Each terminal gets /64. At that time, these are pictures from beginning of this year, so it's mainly 4 months ago. So some things might be fixed in between, but there were some problems with DNS, and there was limited terminal support. Nokia E and N series are okay. Mobile, Windows Mobile, no support. Data cards natively, no support. Versions used, this is Ericsson stuff, SGSN and GGSN, and MPLS Cisco version 12.2. So this is what we have been doing in Slovenia. What is still missing? There's no wide support in mobile terminals currently. There's content-based charging. I know that David will stand up and say it's fixed. Is it? Okay, so there is still no content-based charging. And there is limited or no support for dual stack in terminals. In this, yes, but I will show this to you later. So, yeah. It can be seen there. So, the questions regarding the Go6 Institute, I'm here. Questions regarding IPv6 in T-Mobile, you have the address here and Mobitel there. Anything else, it's me. And now I will try to show you something. What can I do with my phone here from the States? Don't type this address in yet, because you will kill my presentation. So I will not be able to reach it from this one. So this is Nokia N900 with a power kernel from Maimo Garage. And I thank Teemu Savolainen from Nokia for helping me with this. We did this together, and also guys from T-Mobile. And this is not a normal phone. This is a Scandinavian phone, so there are procedures to be followed. Let me see. So I tried it several times, and apparently the DNS here in Google is not always returning the same. Just a second. Yeah, let me try. So, as you can see here, who will hold the phone? Come on, Eric. Here is Apache server running on this phone, and this is the tail -f of the log. Is it?
Yeah. Yep. Chrome.
Okay, so what we have been doing here is this laptop is connected to the local wireless with V6, and this phone is connected with 2 PDP contacts over AT&T network. I don't know why, but it's AT&T, and connected to APN in Slovenia. So here are Slovenian IPv6 addresses, and this is the Apache server responding with a script saying GPRS 0, GPRS 1, which IP addresses are currently going on. You see that wireless interface is down, and we can even do the trace route from this device, from that phone to this device, and these packets are flowing through Slovenia currently. See? That's the trace route from that phone to the machine here. So, yeah. Yeah. It's a border control. So, what we're trying to do here is we can serve the content from the phone. And when I was building this setup for this demo, I had no idea what will come out. And now I see that if I flash if I take the picture with this phone, why should I upload it to the Facebook or somewhere where I don't have the control over the content? You can come to my phone and see it. And I have the control over my content. See? And it was very, very bizarre when we were doing this setup. When I went with this phone in my pocket to watch a football game, my older son is playing football, and I was up there somewhere in the middle of nowhere, and Teemu Savolainen from Finland was hacking the scripts over SSH on this phone that was in my pocket. That's quite bizarre stuff.
Charging you for the bandwidth?
Yeah.
The data plan supports hosting.
So, I think this is it. This is news from Europe. Thank you.
Thank you. Take your phone. Excellent. Thanks. We actually need to make a coffee break, but go ahead.
So you had the Slovenian IP addresses on your handset. My guess is that AT&T doesn't have a roaming agreement. Right, so it's just...
Well, too bad.
Agreed. So I think Frederick has a lot of pictures of himself on the internet around the world doing international roaming of IPv6, and my guess is he's not getting charged for that because the semantics of the CDRs for the roaming aren't supported. So I know.
No. So
this is the dirty little secret, but at the same time, we have to recognize that there are people that are doing IPv6 roaming. Which is the number one thing we need to realize. Number two thing we need to realize is that, hey, it works and nobody had to do anything. But number three is that there will actually have to be follow-up to, eventually, and I don't know who's going to instigate it, but there will have to be follow-up so that there's actually charging in it. I hope the follow-up isn't that
the people who want to get paid will probably follow up. The people who want to get paid will probably follow up. That's usually how it works, right?
Now, the half of this room will ask me to bring them a SIM from Slovenia.
Oh, they can do it here.
No, we're not doing it.
Same phone works on T-Mobile in the U.S.
Yeah, okay, thanks. Anyone else? No. Okay, thank you.
Fantastic. Thank you.